Special Visiting Lecture today with Miss Steffina Morin as the Assistant Professor, Department of Computer Science and Engineering. And for the topic today is Programming Logic and Algorithm Solving Problem Like a Programmer. And for today's session is being live streamed on the Universitas STEKOM YouTube channel. And now I will read our agenda this afternoon. First, we will start class presentation delivered by Miss Steffina. Yeah, and we will start the class today for Miss Steffina. The time is yours. Thank you.
Good morning, everyone. I am Steffina Morin, Assistant Professor, Department of Computer Science and Engineering, St. Joseph College of Engineering, Chennai. Today, we are going to discuss about programming logic and algorithms, solving problems like a programmer. With that, I would like to thank for this opportunity to STEKOM University and also St. Joseph College of Engineering. My screen is visible.
Yes, yes.
Okay. First, in today's digital era, programming is no longer just about writing code, it's about systematically solving complex problems efficiently. There are developing mobile application, designing autonomous system or complex intelligent solutions. The core skill remains the same, thinking like a programmer. Thinking with programming logic is an essential skill for solving complex problems in today. This approach forms the foundation for programming and effective. Why we go for a logic behind the programming before going for the programming. First, we need to know how to solve the problem. Then only we go for the problem. Then only we will go for the programming. What is meant by programming logic means it is not limited to learning a programming language. First, we need to know what is going on, what is our effective tool for solving problems encountered in daily life. Program logic refers to the fundamental principles and rules that governs instructions or commands in computer programming. Every complex problem can be decomposed into a simpler and solver parts. Each and every problem, some may be simple, some may be complex, but each and every problem can be decomposed into a simple sub-modules. So, what we do this, every complex problem has to be its simple sub-problem. So we have to know the logic behind the problem. Then only we can able to split the problems accordingly. How we know that the programming language is to a systematic approach by solving the problems in these four criteria, that is sequential thinking, conditional reasoning, iterative process, and then pattern recognition. That is sequential thinking means you have to know the problem, how to solve the problem. You have to know the set of rules behind the problem, how to process the problem, by step manner with that where some of the problem based upon the conditions or decisions. If you are going for that find out the number, whether the number is even or odd means based upon the condition, whether the number modulo by 2 equal to 0 means it's if it is even, otherwise it is odd. That is like that you have to know the condition, what are the conditions you have to solve, what are the conditions you have to compute in this problem. And then iterative process, whether you need to repeat the actions until the desired outcomes may be reached, and then you have to recognize the pattern. Some of the problems where some of the most of the problems might identify in the similar patterns, that is the similar patterns may can reuse the same pattern again and again. So that is the behind the programming logic. Why the programming logic is important means to improve your problem solving skills, to the precision and clarity in your development in your coding, and then you need to identify and rectify the error. While if you know the logic behind your programming, and also algorithmic thinking, logical thinking, the structured framework, you need the framework behind the structure. The if you first know the logic before you go for the programming means, first you have to know the step by step process or a sequential process behind the problem, how to solve your problem, how to process your input to achieve the expected output. What is in a programming and programming logic? Programming is the entire process of creating a software using any software tools or syntax tools, debugging. It's completely related with your programming, either C, C++, Java, Python, whatever. But in programming language, thinking process, how to solve your problem, what are the calculations behind the problem, what are the computers you need to prove your problem, and then how to solve your problem. It is completely depend upon your own language that is universally across all languages. Problem solving Here, problem solving is the process of identifying and developing potential solutions and implementing the best one. That is, while we solve the problem, you have to know how to solve, what are the things, yeah, you can able to identify. Each and every problem has a multiple number of solutions. So based upon the multiple number of solutions, you have to know you have to find out the optimal solution behind, optimal solution. That is the solving the problem. In any programming languages, including C, involves down a complex task into smaller manageable things, implement those things using an appropriate techniques. Problem solving process. Already we've seen that. What is first of all, you have to understand the problem. Each and every day we go through some problems. Is what is the understanding the problem first? What is the problem? How we are going to solve the problem? That is the main thing. Then planning. Planning means how to solve your problem. That is your step-by-step process. What are the rules behind the problem? If you are going to develop a software for any real-time project, first we need to know the set of rules behind your real-time system. That is called. Then only you can go for a coding. Before the for coding. That is a planning process. Then the implementation. Implementation is purely based upon your coding. First, before going for a coding, we need to understand your problem. Then how do you solve your problem? Where to solve your problem? What are the programming languages behind you are going to use? And then after coding, you are going for a testing. Whether the product is, whether your software product can achieve your analysis or not, can achieve the analysis, can achieve your respective output, can achieve your respective functionalities, that and all behind your testing and the iteration process. After testing, if there is any debugging, if there is any error in that, we have to iterate the process again to get the expected software product. That is a problem solving process. First, you need to understand the problem, then planning, implementation, then testing then testing your software, the software product, then iterating the software product. If there is any error, means you need to get the achievable, you need to go for the achievable output. Then yeah, if your problem solving process comes under, before that we have to, before we go for a coding, we need to do some steps. That is algorithm, flowchart, and then pseudocode. Then only we go for a coding. Programming. What is meant by algorithm? Algorithm is a step-by-step procedure for solving a problem or accomplishing a task. It is a set of well-defined instructions for performing a specific computational task. Algorithms are fundamental to computer science and plays a very important role in designing efficient solutions for various problems. That has already been said. In this algorithm, we have to specify what is your input, what is your output. If you know the expected output only, then only we go for the process. The set of rules to obtain the expected output from the given input. Then the key characteristic of algorithm is definiteness. That is, you have to know correct algorithm, correct procedure before process to your problem, because process to your solving your problem based upon using your coding. First, you need to do definite steps and definite solution. Definite solution, definite thing. And then finiteness, finite number of steps. Each and every algorithm has a certain number of steps, that is finite number of steps. And then input. What is your input? What is your output? You have to know. And then calculating the effectiveness. Before in this algorithm, you have to know the you have to calculate the effectiveness of your program itself. Then your types of algorithm here, sorting algorithms, searching, graph, dynamic programming solution, breeding algorithms. The algorithms are used to from the sorting process, that is sort from whether the numbers in ascending or descending order. Your bubbles are, for example, bubble sort or merge sort, and then searching algorithm, searching certain element in a number of in a list, in a entire list. You need to know the searching the element in the list. First, linear search, and for example, linear search and binary search, searching elements in a sequential order, that is comes under linear search. By searching element and by splitting up the entire list into two solu two submodules, then only you're going to search from the either left or either right. That is a binary search. And then graph algorithm. Here we are going to search an element, or it's like a traversing a order. Graph algorithm is, it is going for a traversing a traversing the solution until you get the optimal solution. That like your mapping, Google Maps, etc. For like that. For example, distress algorithm, depth first search, and the dynamic programming algorithms. That is Here, until you get the optimal solution, you're going for the programming. Then greedy algorithms, it's for example, Kruskal algorithm. Greedy algorithm is also find out the best one until you get the find out the best one by getting the iterative number of operations. How to design an algorithm? First, you need to define the problem. You have to determine the input and output. And then after you determine the input and output, you can break down the problem into sub-modules. That is, then develop the steps for each and every module. Then write the algorithm. Then test your algorithm and refining your algorithm based upon any reviews or feedback from your software testing. Then building blocks of algorithm. How to uh, how to build your algorithm based upon these things. First, statement, stage, control flow, and then functions. For statements, statements are the step which solves a particular problem. What is meant by statement means just a statement. What is a statement? It's like a problem statement to find the sum of two numbers or else to find the average between the three numbers like that. The state is defined as a condition of algorithm and a moment in a time. That is start stage or else stop stage. That is start or end stage, input stage. Whether your algorithm in the input stage, you are giving the input, processing stage, and then output stage and stop stage. Control flow. It represents the arrow statement execution and then directive flow of programs. There are three types of control flow. There is flow of control in your while you are programming. In your first, there are three types of control flow: sequential, selection, and then repetition. In sequential control flow, we have to know what are the steps in that. What are the steps? It like a finite number of steps in a sequential order. That is a step-by-step procedure. Statement one, statement two. Once it processes the statement one, then only it goes for the statement two. Then only it goes for the next statement. Like in sequential control flow, for example, we like just to print the number of just to print some number of to find out the addition of two numbers. For example, if you find the addition to find the sum of two numbers means you are going for the first statement that is you're going for the first statement that is to find out to input two numbers. Then you have to calculate sum equal to for number one plus number two. Then you go for the print sum. Then finally it goes to the end of the program. That is a sequential control flow. So sequential manner, first we need to get the input, then process the calculation, then for computation, then only go for the output. That is a sequential control flow. Then selection control flow means based upon the condition. In some of the problems, you can solve the problem based upon some condition. If you go for example, if you need to check whether the given number is even or odd. Even or odd means based upon the condition whether the number is modulo 2 equal to 0. That is, if your number module 2 equal to 0, that is a condition. That is, if it is yes means the number is even. Otherwise, it is odd. That is the selection control flow. Based upon the condition, the desire, we can get the desirable output. Repetition control flow. In the repetition control flow, that is the same condition. If it is yes means the process the next number of steps. If it is no means it go for the previous statement or else it's any other statement. For example, to print the numbers to print the Fibonacci series also. If you get the yes means you will get the number. If it is no means you go for the further then. In this condition, we may use the for loop, while loop, etc. Functions. Functions is a block of organized reusable code which is used to perform the action. It provides better modularity. They're also called as methods, routines, procedures, etc. Here, each and every problem has its function. For example, if you go for any calculator, if you're going to um, if you're going to program a calculator means that is there are multiple functions: add, sub, multiplication, and division. And then say nowadays in scientific calculator there are sign operation, cos operation, tan operation, etc. So these are called the specific functions. Each and every they are respected to that each and every function. It's like a particular coding for each and every that is to be reusable each and every time. The For example, if you are using if you're in your real time example means you are like a ATM machine. In automated teller machine or banking application, some of the most of the functionalities, account statement, print your account statement, cash withdrawal, and then cash deposit. These are the particular module. So each and every module has a specialist functions in that. Each and every specialized function is and every module has a specialized function in that. So each and everything used to perform that specific action and specific functionality for each and every module. So it only provides better modularity. Here, using a functions only. If you're going for a program from top to bottom, if you split up the problem into your multiple modules or multiple sub-modules only, it gives a better modularity. You can able to, it will gives you a better user interface design. That is a major thing for the function. They're also called as methods, routines, procedures. For example, this is the example for how to write your algorithm. Each and every algorithm, there is first we need to start. There's a finite number of steps. Your problem statements to find the average of three numbers. First, start with step 1 to step 3. You have to write the algorithm like this only. First, you need to step 1. Step 1 starts, if you need to start the algorithm, start with start, then ends the algorithm with the stop. Then first you need to input the pin. If you need to find out the average of three numbers means first we need to know the what are the input we need to give. Average of three numbers, we have the three numbers. That is the your input. I have named the three numbers as A, B, C. If you need to find the average of three numbers, first you need to know the computation behind the process. What is a computation? First you have to know the sum of three numbers, then only divide the sum by the three. That is the basic average concept. This is only the problem solving process. That is your, in this read. Okay, just start with it. Then read the numbers means it is your input statement. Yeah, compute the sum of A, comma B, and C is your calculation. That is your computation process or else a calculation process. This is a process. Process statement is compute the sum of A and B. That is you need to find out the sum first. Then only you need to find out the average when dividing the sum by 3. Dividing the sum by 3, these are the calculation process. Need to start with the right algorithm is first it should be a finite number of steps first. That is, it should be not like a long method. It should be just a sequential step, and also it should be a sequential first. And then your computational process should be in a step-by-step process. First, you need to read the numbers A, comma B, comma C. Then compute the sum of A, B, and C. Divide the sum by 3. Then store the result in the variable. I have the output named as D. That is for average. Store the result in variable D. Print the value of D. That is your output statement. For to write the algorithm for there are need some particular rules and regulations for that algorithm. That is, first one is your algorithm should be clear, precise. First, your algorithm should be clear and precise, and also there should be no ambiguous. That is unambiguous. Your algorithm should be clear, precise, and unambiguous. There should be any more confusing statements. If it is unambiguous only, you can able to proceed your programming based upon your algorithm. That is the first step. Then your algorithm should have a start and stop statement. That is the major rule. Then also your computational statement should be in a sequential manner. If it is any conditional statement means it based upon that. If you have any conditional statement means based upon you have to increase the number of steps with step 3 for 3 equal to step 3. If n modulo 2 equal to 0, if then step 3.1 is equal to step 3.1 is the number is even, and else step 3.2 the number is odd. That is like that. You can also show the algorithm with conditional statements as well as for the sequential control flow, conditional statements as well as the repetitive control flow. This is the basic step how to frame the algorithm. First, you need to have the finite number of steps. It starts with the start and ends with the stop statement. And then you have to know before you know the input. What are the input you need to give? What is your output? And then you have to specify your calculation. Your calculation should be in a sequential order. Then goes with the flow chart. Flowchart are a visual representation of it is a graphical representation of your algorithm. That is a visual representation of steps involved in a problem. They use standardized temples to represent different actions or decisions, making it easier to understand the flow of control of the system. These are the system. First, it is oval simple. It represents a start or end. That is what you are seeing in your algorithm. First step one start and then ends with a stop. That is represented in your oval simple. Then the arrows. That is a connector between the input process and then output. Each and every process should be connected with arrows. Then goes for a parallelogram. In this parallelogram, you are representing your input or output statement. In the rectangle, it chooses the in the rectangle we have to enter your process or functionalities. What are the computations you are doing in your problem solving? Then diamond is used for a decision or any condition you are going to make. Here is a flowchart example. First, problem statement. Same thing. To find the average of three numbers, first starts with the oval simple, start and stop. Then you're going for that input or output statement in a parallelogram. That is input A comma B comma C. That is print average. Here you're going for the in computations in your rectangle. That is sum equal to A plus B plus C and average equal to somewhere 3. That is it is like a flowchart example. Starts with start and then input A comma B comma C. Here you can in the simple flowchart itself, you can able to identify what is your input, what is your output. That is only the major thing behind this simples. Each and every simple has a specific functionalities. For oval simple, it has to represent the start and stop. For the input and output statement, it has to represent it in a parallelogram. For that calculation or a computation, it has to be represented in your rectangular simples. So here, this one only. Then your purpose of the flowchart that is easier to understand, helps to understand the logic of problem. You can easily draw your flowchart in MS Word itself. And then complex problem can be represented using less symbols because if you are using any decision statements, you can use your diamond symbol itself. Diamond symbol is a purpose for your to represent any conditions you are using in your problem solving. Then it is a way to documenting any problem. It is helps in debugging process. If you're in your flowchart itself, you can able to identify whether the problem is whether you can able to identify and rectify the problem itself because it's you can able to see the flow of the problem. You can able to see the flow of the problem, where it starts, where it ends, where it goes accordingly. Then comes under pseudocode. After flowchart, first before going for a program, first we need to write an algorithm with a finite number of steps. Then we need to process the flowchart according to your algorithm. Then we go for a pseudocode. Pseudocode is a completely human readable description of an algorithm with some natural language. It is also like a same like an algorithm, but with in an algorithm it is a clearly understandable language. Overall, in your own language, the algorithm should be written in your own language with a clear and precise. But in pseudocode, it should be in programming constructs. What are the programming coding also? Just you're writing your syntax. It has some if, else, and then if else for loop. That and all some conditional statements are also represented, can also be represented in your pseudocode. This is a high level language. It's a human readable description of an algorithm using that natural language with the programming constructs. Here, it simplifies algorithm design before coding and then it is language independent. But it is language independent. We cannot proceed the pseudocode into your any programming, any software because it is a combination of both the human readable concept as well as the programming. So that is a combination of both. So you cannot able to use it in your programming construct. It has a programming construct, but you cannot able to do it any can't use it in your any programming software. For example, here begin, it starts with in a algorithm we starts with start and stop, and a flowchart we starts with start and stop in a oval begin. In the pseudocode, we starts with begin in the process. Begin your program and then end your program. Here you are using input number 1, comma number 2, comma number 3, and then your computation. Each and in the pseudocode here, there is a rules to write a pseudocode for a, excuse me, sorry, I'm coming back with. So in example pseudocode, starts with a begin, and then each and every starting phrase should be in a capital letters. That is begin, input, calculate, and then compute, output, end. Each and every starting phrase should be in a uppercase letter. That is your um, uppercase letter. That is entirely caps. Then your other statement should be in a lowercase, or else you can able to know that either input statement sum is in your sentence case like that. So begin input number 1, comma number 2, comma number 3. We are going to input three numbers and then calculate sum equal to number 1, number 2, compute. Average equal to sum by 3, output average, enter. This is your pseudocode. And write on pseudocode. This is your programming logic flow. Already we saw behind from algorithm in flowchart in pseudocode. This is a this is a logic flow behind your programming. First, you need to know the input. What is in by input means your data going to be processed and then the parameter and then your user input. Then process. What are the logical steps to complete your output and then your calculations and your decisions? What are the decisions your comes under in your process? Then finally, you're achieving your output or a result or a result. Output in the other terms of result. Then, how to coding? Before going for a coding, you first know analyzing your problem. First, we need to analyze the problem, designing your algorithm. That is, you are going to analyze the problem. First, you need to understand the problem. What is your statement? Either if you are going to do any software related project, or else any software, you are going to develop any software, or else any particular model, you are going to design any particular models. You have to know to analyze the problem. What is the behind the what are the gaps behind the existing system and all also. Then go for the design. Design means first you need to write the algorithm within a finite number of steps and a definite number of steps with a correct sequential order if there is any condition in your problem means you have to specify in this algorithm itself. You have to specify, you need to specify in that algorithm whether if you're following if you're following the sequential control flow, or else if your problem statement is based upon your any decision algorithm, or else decision statement or any starting statement based upon, you have to design the algorithm. Then based upon your algorithm, you have to design your flow chart. Then go for the problem coding your problem. That is your programming language. Then next you're compiling your problem in any software tool and execute your problem. Then testing your problem to identify the any errors, and then rectify errors. Then completing the after completion of your entire software product, after completion of your entire development of your software product, goes for the documentation. What are the things you need to documentation is your algorithm, your flowchart, your Zero as well as your programming, and then what are the testing process behind that. The entire thing should be documented. This is your programming logic behind the you have to think like a programmer. First we need to analyze the problem. You have to understand the problem, and analyze the problem is you have to go through with a certain number of steps. Every problem has a multiple number of solutions. So each and every problem has a multiple number of solutions. So you need to find out which one is optimal, which one is best for solution to follow. According to that optimal solution only, we go for that algorithm process. Then you go with the flow chart. Flowchart is a graphical representation of the algorithm. You can able to easily achieve you can able to easily view your input or output and the process in your flowchart. And also your pseudocode. Pseudocode is completely comprises of your human language as well as your programming constructs. After that pseudocode, you can able to easily framing your coding. You can easily develop the coding and then a compilation process. After compilation and execution, you need to go for a testing. Whether you achieve your expected output or not, whether you reach your expected output or not, and then debugging the process. Debugging means correcting the errors, which you have found out in your testing process, and then go for the documentation of your entire process. Then go for the programming. This is the final one. This programming is the process of designing, writing, testing, and maintaining instructions that computer can execute to solve specific problems or perform a desired task. It involves translating human ideas and requirements into a language that can easily um, understand and execute. That is, your programming is like a process of designing your problem, designing your designing a solution based upon your problem. That is the basic. Programming is a designing your solution based upon your problem statement. A simple process of designing, writing, testing, and then maintaining, writing your code. First, you need to designing your structure. If you are going to planning for a plan, if you are going to plan to construct a house, first you need to go for a designing process. First, you need to go for a blueprint of your entire home or entire home. Then only go for a code. Then only go to construct your house. Before the, it's like first the flowchart is like a blueprint behind the programming. It's a algorithm as well as algorithm is it's like you're writing your entire statements in your own language. In your flowchart is it's like a graphical representation or a blueprint behind your programming. That is, you are going to represent your input, output, as well as what are the process behind, what are the process or the set of rules to follow to achieve your expected output. Then you go for the programming. Means if you complete the algorithm flowchart, then if you go with the programming means you need the clear structure or structural framework of your program. You may understand what are the things you need to fix in your program. That is for after the header statement hash includes hash stdio.io. Here is a for example program. Here hash include stdio.h is in your header file. After the main statement, I need to specify that input. Specify the input, that is your data type, and then variable name. Int is your data type, and a num1, num2, num3 is your variable name. And then you need to printf statement. Printf is expecting output, that is you enter three numbers. And then scanf, you are getting input. Percentage F, I am getting that input in that hash number 1, number 2, number 3, and then average. Here I'm computation. After the computation, I'm just going to print off the average number of three numbers is return 0. This is your example programming statement. I need to show it in my. I'm going to solve the problem is because first you need to input the solve the problem. I'm going to solve the problem in C. Sorry, good job. First, you need to start with this is your header file. Then this is your main function. Starts with your main function, and then you have to input the number one. No, three. If you go for the computation means first sum equal to before that you need to mention what are the things you have to specify in your each and every step. That this is at in C it is a procedural language, so we need to specify each and everything. What are the inputs you are going to use it in your system, use it in your entire program, and also your output for each and everything, and also the final state. Semi-equal Uh, the average that is equal to sum divided by 3. Each and every steps is the print statement is going to be average of three numbers is, if it is, I need to get the output in integer format, so percentage d. We need to get the output in float format means percentage f. Then I need to in the average. To start the program. This is your programming structure in C. That is your first need to specify the header file. That is your standard input. STDIO stands for standard input and output. This is your header file. Hash include stdio.h. That is your header file. It consists of all the input and output statement. That is a predefined statements. If it is printf and scanf, etc. First, we need to, before that, I need to get the input first. Enter three numbers. Scanf. That is percentage D, percentage D, and then percentage. I'm getting the inputs in integer format, so I'm using scanf percentage D. This is something. For hash include stdio.h int main, and then I'm using that I'm declaring the variables. That is I'm declaring the variables with int main, and then printf enter three numbers. Scanf number one, number two. So equal to number one, number two, number three, number. Enter three numbers if I run the program. Sorry. Mhm. So I need to rectify eight number long-term entries on average. Enter three numbers, cap, percentage, and getting the numbers. And sum of 30, we're adding average and weighted. So fault in you can achieve it in the Python also. I already entered. In Python, you can able to directly segment the directly. If you need to, you don't want to get the enter the variable allocation in the variable declaration. You may directly a equal to int input of enter the first number and the second number and then average of a plus. You can directly compute the statements. Average of three numbers is an average. And go back to my presentation. Thank you. Thank you for this opportunity. I have got some questions. How does learning algorithm thinking differ from simply learning a programming language syntax? And why is it more important in the long run? How does learning algorithm thinking differ from simple learning of programming language syntax and why is it more important in the long run? Because if you're thinking you're because if you're going for a if you're going to do any large programming concept means you first need to know what are the steps behind your programming. Then only it is that's why algorithmic thinking is more important because it is not just a a simple statement. It is not just a simple statement. It's like before you go for the programming language syntax, if you're going for the programming language syntax, you have to know how we are going to solve the problem. What you are going to solve the problem, how we are going to solve the problem. In your algorithm thinking means you first know how to compute the problem. Yeah, what are the input, what is your output, how to process your statement. That only you frame in your algorithm itself. Then after framing the algorithm, before going for the coding, if you framing your algorithm means you may know the step by step process. Then only it is important in your long run process. The algorithm for if your algorithm is the documentation is more important in your channel everything. Algorithm documentation is important. That's why it is more important in the long run. If you're going with one project, if you're doing one project, if you're leaving from that project means someone else taken the same route. So he needs to know what are the basic things you have followed in that programming language syntax. So algorithmic is basically more important in the long run process. To what extent should beginner Kinan asked? To what extent should beginner programmers focus on mastering logic and problem solving before dividing into frameworks and tools? To what extent should beginner programmers focus on mastering logic? First, you need to solve the problem. Um, first, if you are going for a solve a problem means first you have to mastering logic means how can solve the problem. Each and every problem is a multiple number of solutions. So the multiple number of solutions is based upon the multiple number of solutions. You may see itself. You can get the basic idea about that. So you can easily identify the framework and tools in algorithm perspective or logical thinking perspective, in based upon your if you are thinking like an algorithmic thinking means you can easily be dividing your entire module into a similar sub modules. So you each and every module has such a framework. That is your every sub module has the entire structure or a framework, structured framework, and each and every has the same structured framework. So based upon the framework, you can mastering your logic. How can we ensure that our algorithmic solution are not only correct but also efficient and scalable? Or not only correct but also efficient and scalable. You can able to measure your algorithm based upon your time complexity as well as your space complexity. This is a basic thing. Your algorithm, how can we ensure that our algorithmic solutions are not only correct but also efficient? Means your efficiency based upon your time, amount of time required to solve your problem, and also amount of required based your functionalities can run in your program, and then scalable. Your measure of your time, the amount of space required to save the problem. That's it. Is there any other queries?
I guess no one else asking again, ma'am.
Yes.
Yeah. Okay, I guess no one else asking again. Yeah, thank you so much for your answering, ma'am. Yeah.
Yeah.
Okay, yeah, before I close this event, for all participants, please open your camera. I will take a picture on the count of three. Okay, one, two, three. Okay, another one, one, two, three. Thank you for your cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Miss Steffina for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have a collaboration in the future. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice day. Thank you so much, ma'am.
Thank you. Thank you for this opportunity.